All right, how's it going, everybody? Today we're going to be talking about series circuits, and specifically how to solve them. Okay, so a series circuit is really just a single path as opposed to a parallel circuit, which is multiple paths. Over here we have the circuit diagram symbols so that we know what we're talking about here. The thing is, with drawing circuits, you have to be very precise and very careful that everything is nice and neat and organized. That's the whole point of a schematic diagram. So you can't always get credit if it is a little sloppy. So just take your time as you're drawing these things so that you get it as close to these symbols as you can, and that all your things meet at right angles or as close to them as you can. So series circuit has specific rules that it follows because of its orientation, because of the fact that it has a single path. We're going to add to those rules a little bit, or at least just give them our own spin, and we're just doing this really for our own personal bookkeeping. So we already have the 1s, 2s, and 3s, and so ons in there, but instead of just leaving those things on the left-hand side as, just the I's and the V's and we're going to label them all as having a total, which is what that little t is going to stand for. And again, that's really for bookkeeping. And so we can label these kinds of things. So the battery is going to be total. There we have R1, or we're labeling that 1. So the current I that goes through that R1 is I1, and the current that goes through the battery there is I total. And that way we can keep track of and answer those questions specifically. REQ is equivalent resistance. It's the total resistance, sort of. It's what the resistance of the whole circuit is. So it's not really a total, because total implies, some kind of addition. But we're going to call it the equivalent resistance. So we're going to use these rules in conjunction with Ohm's law in order to solve these circuits. And it's going to be a lot like a Sudoku or something, right? You solve one and it tells you what you're going to do with the next thing. So every time we get a new piece of information, it's going to lead to being able to solve something else. And we'll see what that means here in just a second. So first we're going to start off with a pretty typical circuit problem. A one resistor circuit is kind of silly to go through this whole process with. So we're going to move into a 2 resistor circuit, and you'll see why in just a minute if I can actually draw this thing. All right. So you can see I'm being careful in the program here. Wants me to do weird things with all these squiggly lines. But I'm trying to make sure that I have straight lines that meet at 90 degrees and that everything matches up. So one thing that you'll notice here that that is technically wrong, but it is not, I wouldn't take any points off for it, is we have 2 sort of squiggles on the left-hand one and 3 sort of squiggles on the right-hand one. But when I write this out, they are both 5 ohm resistors. So really they should have the same number of squiggles, the same numbers and ups and downs. Okay, so we have a 20 volt battery and we have those 2 5 ohm resistors, and we're going to try to solve for everything, which means we're going to try to find all the things that we don't know about this, which is really, in this particular case, just the current. So you could say, what is the current through resistor 1, what is the current through the resistor 2, and what is the current through the battery? Well, if we remember what the rules are from above, each one of those currents are the same. And later on we can talk about why exactly that is. For right now, we're going to work on just the mechanics of solving this circuit. So we have a recipe. The first step is to label these things, which I've already done. Labeling as 1, 2, and total. And it doesn't matter which is 1 or 2. We're just doing it really to keep track of which one is which. All right, so now we're writing Ohm's law for each of the objects in the circuit. So we have 3 objects here, which means we're going to write Ohm's law 3 different times. Once for the battery, once for the first resistor, and once for the second one. So we have R total is equal to I total, R total. We have V1 is equal to I1, R1, and we have V2 is equal to I2, R2, D2. There he is, in all his glory.
This is the drug police. Pull over.
Let me just get rid of him. And there we go. So, yeah, it's a little different. In the classroom, I would normally, every time I would write R2, I would say D2. And just like it's 1 o'clock. right? Okay, so the third step here is to write the rules for whatever circuit. So this recipe thing that we're working on here is going to work for series circuit and it's going to work for parallel circuit. So I kind of generalize this as the type of circuit because the rules for series are different from the rules for parallel. So I write down the first set of rules, which is V total is equal to V1 plus V2 plus V3, except we don't have V3 here. We have R1, we have one resistor, right? And we have a second resistor, and we have the total, but we don't have a V3, so we'll get rid of that. There's no reason for us to write it. We wouldn't be able to solve it if we left that in there. So we're only writing it for the appropriate number of things that we have. Just like we wrote Ohm's law for each one of those objects, we're going to write down this for each one of those, the rules that correspond to each one of those objects. So I write down the same thing for my current, all right, and then if we just copy, there he is again, R2D2, if we just copy down the rules, we end up wanting to get rid of the REQ just so we have like all the totals, and so they match up nicely across the bottom, and they match up with the way we've written it across the top. So I get rid of the REQ, and I just end up with our total. Okay, so total there, and total there. That'll match up above. Okay. The next thing that we need to, what do we need to do? Okay, so we have everything labeled. We have step 1 done, we have step 2 done, step 3. All right, so step 4. Step 4 is going to just really to be a substitute in the values. But the thing is each one of these values has 2 places that it goes. Right? It has sort of that place to go in Ohm's law, and has a place to go in the rules. And then we just need to solve this thing. And you'll see pretty quickly that once you put in all the information, you'll have at least one of these equations that you can solve. Okay, and then as soon as you solve one equation, you get another piece of information that you can then put somewhere else. And then when you put it somewhere else, then that allows you to solve that next equation, which means that you have a new piece of information that you can put somewhere else. So it's kind of this domino effect. And then the nice thing at the end is that it's going to check itself, because it's got to be self-consistent here between the top row and the bottom row. All right, so I've got all my information in it. It goes in 2 places, right? We have the V total written in 2 places, and because we have the same resistance here, they each go above and below. R1 above, R1 below, R2 above, R2, D2 below. All right, so we have all of our information in now. We only have one of these equations that we can solve. We can't solve any of the Ohm's law equations, and we can only solve one of the rules equations. So we'll get to that in a minute. Just in terms of what the currents are, right? So we're ultimately, that's what we're kind of looking for here. It's the only information that we kind of don't have, I guess, although we don't have the voltages. So the current that goes through the battery would be I total. The current that goes through resistor 1 would be current 1, all right, and then so on. But really they're all the same, right? If we look down below, in a series circuit, the current is the same everywhere. So it's the same current that flows through each one of these things because of how it's wired, right? It's a single loop, right? It's like a whole bunch of people holding hands in a circle and then if one person walks one direction, everybody has to walk that direction. All right, so we can add up resistor 1 and resistor 2 because that's what the equation says, and we have enough information to do that, and we get that they are equal to 10 ohms. So we take that 10 ohms and we can bring it on up because we have that new piece of information, so we can put it in a new place. So our total is 10 ohms, so we can bring that up and put it in that first line where our total is now equal to 10 ohms, which means now we have only one unknown in this equation, which means we can solve this equation, which means we get a new piece of information. That piece of information is I total. Now in a series circuit, once you have the current, you have quite a bit of information. All right, I'm just going to write this down. I total is equal to 2 amps. 2 amps. So we move that down? Yes? No? Okay. So we move that down. Come on, pastime. All right, so anyway, so we're going to move that down there, sorry. And now we have I total, we have I1, we have I2, which means I can now put that above for I1, and I can solve that equation. All right, so then I put that up there. It's 2 amps, which means, and I can put it over here. All right, put it there, and that's 2 amps, and that means I can solve both of those equations now. I can say that, well, I can now say V1 is equal to 10 volts, because it's a voltage, and I can put that over here now. Every time you get a new piece of information, it goes somewhere else. All right, and I can solve this one. V2 is equal to, again, 10 volts. So each of them has a potential drop of 10 volts across them. You could say it that way. The potential difference across each of those resistors is 10 volts. And when we have each of those potential drops, we can say, well, the total voltage is 10 volts plus 10 volts is 20 volts, and that matches what we said before. Hooray. Okay, so that's the gist of it. That might go fast. Hopefully you can play this back if you weren't sure. Ask questions if you have any about this, and that's pretty much it. Okay, so that's how you solve a series circuit, and we'll see you guys soon.